Morning. Testing. Yeah, does it work? Okay. Good morning, everybody. I hope you're all enjoying INTERSPEECH. I certainly am. I'm honored to be here today and to be able to introduce our keynote speaker, Professor Rupal Patel. Rupal is the founder and CEO of Vocal ID, which makes custom synthetic voices. Vocal ID is a spin-out from her research lab at Northeastern University, where Rupal is a tenured professor. Vocal ID was recently acquired by Veritone, where Rupal is now the VP of Voice and Accessibility. And please give a hand to welcome Rupal to the stage today. Thank you.
Good morning. Thank you all for waking up this morning after the parties last night. And thank you for those of you who are joining in virtually. As Esther said, my name is Rupal Patel, and I'm really honored to be able to give this talk. So I wanted to thank the organizing committee and all of you to be here. So I'm going to talk today about opportunities and challenges that are coming forth because of the advances in speech technologies. In particular, I'm going to talk about synthetic speech. And the title of my talk is about the blurred lines, because as you've heard today, or this entire conference, you heard from Professor Lee earlier this week about how speech technologies are just accelerating and advancing so rapidly. Particularly with speech synthesis, there are also unintended consequences. And I do want to bring our attention to that because as a community, we can do something about that. But I also think it's a really exciting time for us to be in this field. I think about it as being no better time to be a speech scientist, because the work that we're doing has so much impact, both for industry as well as social impact. Okay, so The outline of my talk is going to be in sort of 4 phases. First, I'm going to talk about the early days. Most of you in this room probably have read about some of the early days of speech synthesis in your textbooks, probably even heard the samples. But the reason I want to play these samples again today is because rarely do we listen to these samples back to back. And when we listen to them back to back, we kind of see the progress, because otherwise our ears are just so tuned to listening to Siri and Alexa and all these amazing voices today, but we forget where we've come from. So I'm going to talk a little bit about that. And then I'm going to talk about a particular project called Vocal ID, or a company called Vocal ID, and about the fact that we used this technology for a specific social good, and that was for people with speech disabilities. And there, I'm going to talk about a theory of speech production, source filter theory of speech production, which you all know about, but how we applied that for this particular use case. And then I want to go into today, right? The perfect storm. The perfect storm between new machine learning techniques, which has accelerated speech synthesis research in the last 10 to 15 years dramatically, and also the advent of, or the introduction of headless speakers and phones and so on and so forth, on which these speech synthesis technologies can run. And so what does that mean? What are the new applications there? And last, I want to touch on the new horizons. In each of those use cases, I'm actually going to illustrate how it's not just about the core speech synthesis technology. There's a lot of other pieces along the way that are also really important. And so that's really where I want to end, with this sort of aspiration about where we can go from here and what us as a community at INTERSPEECH can do in the next decades. Because we've heard a lot about the fact that it's so good already, but there's still work to be done, which is great for all of us that are researchers. And there's much to do that actually can impact other industries and other verticals as well. Okay. So a brief history. Back in the 1700s, we had these mechanical models of speech production. We had the Euphonia by Faber, Bell Labs Voder, which you're going to hear in a bit, the pattern playback machine, concatenative synthesis, unit selection, and now there's all sorts of methods of neural synthesis, right? And so just this little video to just get your ears tuned to where we've come from.
There are 10 filter circuits in the motor, and combined with the 2 energy sources, they give a total of 20 separate components to be used in building up speech sounds. But now let's have Mr. Garrett and Miss Harper actually show us what the motor can do with these 20 separate sounds.
Well, we've heard the voter make a word, and by combining words, of course, we get a sentence. For example, Helen, will you have the voter say, "She saw me"? She saw me. That sounded awfully flat. How about a little expression? Say the sentence in answer to these questions. Who saw you?
She saw me.
Whom did she see?
She saw me.
Well, did she see you or hear you?
She saw me.
Now, so far, you have only heard the...
So you get a sense of, it's changed dramatically, right? And prosody, we were working on prosody even back then, the contrastive focus and so on, and it has dramatically changed. Another set of research that actually continues to go on is articulatory synthesis and work in how to really scientifically understand speech production. So sometimes it's not just about how clear and pleasing the sound is for synthesis. It's also about what can we learn about speech production, what can we understand about human speech production, and some of the articulatory models are really trying to get at that. So maybe the synthesis isn't the best quality, but it's really trying to uncover what we know about speech production. And so I'm just going to show you a little sample of this model that is trying to illustrate some of the tissue dynamics as well as the airway dynamics of the vocal tract during speech production.
This mechanical talking robot mouth, developed by the Sawada Group at Kagawa University, features speech organs which mimic a human's.
今日肺に当たる空気のポンプは持ってきてないんですけれども
Listens to the sound it is making through a microphone, and then determines by itself what motions will make it sound more human.
So you see the training that's happening as you're learning to speak. And so we're seeing this in models, computational models, as well as these mechanical models, trying to better understand human speech production. Okay, and then many of you all know about concatenative synthesis. And so today, most of my talk's actually going to be about neural synthesis, but I just want to basically take a little bit of a note of where we've come from so that we can see what progress as a field we've made. Moving on to vocal identity, or vocal ID as we call it. This came out of the research that I was doing, both as actually a clinician. So I was trained as a speech-language pathologist. And then as I was working with kids with speech and language disabilities, I was really fascinated by, initially, ASR, automatic speech recognition. And the naive thought I had was that we were going to be able to make a machine that could understand disordered speech, because disordered speech and particular kinds of disorders are relatively consistent, for example, in dysarthria. And thus, if they're consistent, and even though they're impaired, just like a very strong accent, the system can learn to differentiate when the person says it in a particular way that they mean X, right? So this is why I started my PhD, and my PhD was really more focused on building this automatic speech recognition system for dysarthric speech. I quickly learned within a few years that that was more challenging than I actually expected it to be. And I got more into the acoustics of speech production. And there, I noticed one thing as a clinician, which was even when individuals who have severe speech impairment try to vocalize, they may not be understood by you and I in terms of what they're trying to say. But what they mean or their intent is often known to their familiar communication partners or understood. And sometimes we chalk that up to be, well, that's just context. They know what to expect. But there was more than that. And I focused in my PhD really on the prosodic elements of their voice. So even though they couldn't control the filter, the vocal filter, they could still control the source of speech production. So vocal fold vibration as well as the laryngeal support, the respiratory support for speech. And so we took this pretty simple model of speech production, which you all know to be source filter model of speech production, where the source is the vibrations of the vocal folds and the air pushed through that. And the filter, which is the rest of the vocal tract, being shaped in different ways in order to produce consonants and vowels. And in you and I, as I'm speaking today, source and filter are combined. And when we measure it at the microphone or when we record a voice, we're recording both source and filter together. But in these individuals who had very little ability to control the filter, could we, in fact, use source filter theory and decouple source and filter and then recombine it digitally? So the idea was that the individuals with severe speech impairment due to things like cerebral palsy, ALS, multiple sclerosis, all these different kinds of disorders where they cannot control their lips, their tongue, and the other articulators, where they could still have some identifying voice, right? So oftentimes, many kids would have the same exact synthetic voice in a classroom if they had multiple disabilities, right? But when you heard one of them coming down the hallway, you would actually know which one it was because when they vocalized, they had distinct vocal identities. And so that's what we were capitalizing on. And so we were going to just get the source characteristics from our speaker that we want to make a unique voice for. And we would borrow the filter characteristics from someone who is similar to them in age and gender, accent, whatever else. The clarity would come from their surrogate voice donor. And why were we doing this? Back in 2002, which is really when some of this research started, you know, I had actually walked into this exhibit hall, much like the ones we have here, but it was in one room. And what you would see is at that conference, this was back in Dublin, actually it was in Denmark, all the vendors are in one place, and many of the actual users of this technology would also attend this conference, as well as clinicians and scientists. One of the things I noticed is that, you know, many people were using the exact same voice, regardless of age or gender, right? This is back in 2002. We don't have the technology we have today. We didn't have that customization potential. So the idea was, could we actually build a voice that was personalized to them so that every individual could have a unique voice because they had a unique vocal identity. And so if they're going to use this device to communicate, you know, we're giving them a talking box, we might as well give them one that is much more representative of who they are, because voice is identity. You and I have a voice, and we often take it for granted. We often think, you know what, I don't like my voice, I don't like the way it sounds. Many people think that, but if your voice is lost, that's when you recognize how much of a part of you it is, and that's how people remember us. So I had a chance to talk about this research back in 2013 at the TED Women Conference. And at that time, it was really just the science of what we were doing and how we were inverse filtering and separating the source and filter and recombining it to make these voices. Like a handful of voices that we'd built in the lab. I talk about this work, and at the very last part of the presentation, I asked, well, what if you could volunteer your voice? And we honestly thought maybe a few hundred people would sign up. So we had this one website to say, if you want to donate your voice, at that time it was 7 to 10 hours of speech that we needed from each individual. Think about this. We thought, who the heck's going to sign up for that, right? There were thousands of people who volunteered to donate their voice. And that actually started Vocal ID. So what we did first is we built an online system to collect samples. Because what was happening before that is people were coming into our labs and we were recording there, but we were getting voice donors from all over the world. And that meant that we needed to create a voice voice donation platform that was online. And so I'm just going to step you through what it looks like. It's been through a couple of iterations now, but essentially it's a UI where you have the lines that we want to read aloud, and one by one, you read them aloud, you can play them back, and it just moving around with just the arrow keys on your computer. So, and you can also switch stories and so on and so forth. No different than what we've been doing in the labs, but just making it available to more. But of course, riddled with issues, right, in terms of the quality of the voice you can get, whether or not they're in a reverberant room, whether they have the dog barking behind, whether they've got the TV on, and so on and so forth. And so that itself was a massive challenge in order to get good quality data. But today, we have about 95,000 people who have contributed their voice. Not all of them doing 7 to 10 hours, because over time we were able to reduce the amount of data that we needed. 18 million sentences, people from 120 countries. So this is what we call the Human Voice Bank Initiative, and it continues to grow. We're also working with a number of different organizations to make sure that we get representative voice from across different age groups, as well as accents. Only in English at the moment, and hoping to actually move into some other languages in the near future. Okay, so what do you do with that? So who is this for? It's for little girls and boys and people who have these severe speech impairments, right? So this young girl, her name is Maeve. Maeve was 9 years old when we started working with her. And one of the impetuses to start the company was because her little sister, who was 12, I think, at the time, had written me an email saying, I really want to donate my voice for my sister. And there were many of these kinds of stories, and we just thought, how can we do this at scale? And it can't really be in the lab, and it had to actually come out of the laboratory. So what can Maeve do with her voice? This is one of the biggest challenges, is to get those representative samples of data from individuals who have such severe speech disorders. Because when you have a motor speech disorder, the initiation of voice is actually the hardest thing. So they make sound, but actually having them initiate spontaneously or volitionally to create that sound is where the real challenge is. So sometimes you get sounds like this. Giggles and just trying to get the air out, right? And finally, sometimes we get samples like this. What can you do with that? We can do source filter separation. We can try to get as much of the voice identity from her as possible, and then use that to then find the closest voice donor. So I'm going to just step you through that. This is a schematic, right? Because, of course, this is a multidimensional space. And so you've got your recipient, Maeve, in this multidimensional space with a number of characteristics of her voice. And then what you're going to do is search through this multidimensional space for all of the closest varying donors or surrogate voices and find the ones that are most consistent. In this case, she was one of our first recipients, and both of her sisters contributed their voices, and we didn't want to cause any sibling rivalry, so we didn't tell them which voice was actually the one that got which one we combined together. Typically, we do not combine the voices of siblings because we try to keep the identity relatively anonymous, just for multiple reasons. Okay, so let's just step through an example. Now, I want to say that the sample you're going to hear today is a sample that was produced for her back in 2018, and there are some challenges actually in terms of using the more sophisticated methods of speech synthesis with the technologies that they use, but just to give you that. So we're going to start off with just the vowel sample again. And then you have a whole database of recordings from the voice donor.
Ice cream is my guilty pleasure.
After the source filter separation of both the recipient and the voice donor, you're combining just the source of the recipient and just the filter as much as you can. We all know that with source filter separation, it's like separating egg white from egg yolk, and you're going to get a little bit of both, right? And so we're going to combine the source only as much of those characteristics and the filter for the voice donor. So about 3,000 sentences. We morph those samples, and then we feed those morphed samples to the neural engine now. It wasn't always a neural engine. Initially, it was a concatenated speech synthesis system. And then you get something like this.
I can't wait for my friends to hear my new voice. My parents are really happy I'm not addicted to Fortnite. I want to meet Taylor Swift.
These are some of the things that she wanted to say with her voice when she first got it. As you can hear, in comparison to the voices that we can build today, it's not as clear, it's not as sophisticated, but as I said, this is a continuing march of technology advancement that we're going to be that we are working on. But the devices that they have to use are typically not as advanced as our phones. And so the technology that can run on those devices is typically a few generations back. And that's really what some of the new challenges are, I think, is in compression and creating neural models that can be supported on these devices. And sometimes they're also locked, meaning that you can't use them. They're not internet available. So you can't use anything that is on the cloud. It actually has to be embedded. Okay, so this is really this is the core crux of what vocal ID was all about. And what we learned, though, is that it wasn't just people who had not spoken before or who had used devices or voices that were unlike them. In fact, Maeve was using an adult female voice for many years, and at the first time, before that, she was actually using an adult male voice, right? And so the fact that she can now have a voice that's uniquely hers changed a lot of interactions for her. And that's one of the things, is that people start seeing them as individuals, and over time, just like your voice and my voice changes, there is something that is very important in terms of engaging in actual social interactions with that. The other thing that we started learning is that many people were coming to our platform to actually record their voice for themselves. So again, this was not really novel. People had been making speech synthesis systems for individuals for some time. But what we allowed them to do with the Vocal ID platform is allow them to do this remotely and easily. And so we had people like the next gentleman on this slide, Lonnie, who recorded his voice prior to a laryngectomy and a total glossectomy. So this is his voice before. He's 2 weeks before the surgery, so you're going to hear sort of change and raspiness in his voice as well.
The only thing I liked in school is arithmetic.
And he banked several hundred sentences. He didn't get to quite the 2,000 or 3,000 we were recommending at the time. But again, there's no morphing involved here. It's just plain old, build a speech synthesizer for them, and create a sound like this.
My family threw a surprise birthday party for me. There was close to 100 friends and family. Most had not seen me since my surgery, but thanks to your technology, they heard me instantly recognizing my voice.
So, I mean, there is so many changes, and the fact that many of these individuals with laryngectomy typically were just given electrolarynx to use. So instead, the use of a speech synthesizer where they would have to type, so it's not completely without any other challenges, but we were starting to see that that was actually could become the standard of care. And only this year have we been able to, last year, sorry, in 2021, were we able to get the Veterans Association approval to be allowed to have these voices be reimbursed by the Veterans Association. So now we're working with hospitals and clinics in the US as well as in Canada to provide this as a service as well. What I want to show on this graph is the change. So from 2014, when we first sort of launched out of the lab, to 2018, there was quite a change. And you've heard about this in all the posters and the presentations you've been listening to this week about how speech is getting better and better. So again, just for your ears, here's a sample of an individual human speech production.
Please tell me if you don't understand what I am saying.
And then, get ready for this, it's 2014, definitely not quite there yet.
Please tell me if you don't understand what I am saying. Please tell me if you don't understand what I am saying.
2016-ish, now we're getting to DNN, RNN synthesis.
Please tell me if you don't understand what I am saying.
RNN synthesis in 2017, and then...
Please tell me if you don't understand what I'm saying.
That improvements in vocoder, still not the neural synthesis, because, again, like I said, it can't be used on those devices. So, huge change. I think social impact there is something that I'm really proud of and excited about the advances that we can continue to make here. So what's next? So now moving on to the today, right? What we know today. Back in 2014, 2016, when Amazon and Google started creating, filling the world with these headless speakers, right? The Echo, the Google Home, and so on, we had new opportunities. Along with that came new opportunities with machine learning advances, and also the open source movement. I feel like before that, there was open source, but I think the real adoption of open source really has opened up a whole lot more. So the next two slides, I want to go into what is the precursor. When you think about your cell phone, the phone came first, and then all the software, because that platform allowed for the developers of all types and people with imaginations and applications that were never even dreamt of by the actual producers of the iPhone. That's what made adoption so incredible for the iPhone and for basically mobile phones. So the hardware often sort of precedes the software, right? So what you're seeing here is that even with speech recognition, prior to some of these hardware platforms, speech recognition accuracy wasn't the best, right? And also not great for different accents, for people that are fast speakers, and all sorts of different kinds of variety of speakers that you hear out there. As the progression of the technology increases, so a lot of the hardware platforms as well as the utility here, you're seeing recognition accuracy beginning to look at parity as well with human recognition. And even humans aren't perfectly accurate at recognizing one another because we don't always speak accurately, right? And so again, I just want to show this in terms of recognition was first. And typically in our fields, ASR sort of precedes text-to-speech for some reason, I guess. The other thing in this graph I want to show is the speed of adoption of the technology of smart speakers. So when you think about things like computers and the internet and radio, took years, took 20 years or so for those kinds of communications applications to take root, for people to adopt them, for there to be market penetration. But the TV was adopted faster. Many of us wanted that, right? We wanted something that was more interactive. And then smartphones, quicker adoption. Smart speakers are the one technology that's the fastest growing adoption that we've seen. Who knows what the next adventure is? But I think one of the things here is that accelerated speech synthesis technology dramatically. Because not only did this thing need to understand what you were saying, it was going to speak back to you. And initially, it was going to speak back to you in a few branded voices, right? But that gave us opportunity to think about what else can be done. So I think I bring this up because I feel like sometimes the trends, you have to have a base there for the adoption there to be possible and to get people's imaginations going. So today, there are 124 million smart speakers in the US alone in 2021. 4.2 billion digital voice assistants globally in 2022 and projected to rise to 8.4 billion by 2024. So there's mass demand for this. And there's also a demand that we don't all want to hear the same voices. It's great for some brands and some companies. You talk about Siri, talk about Alexa, and so on and so forth. That voice is basically synonymous with that brand, and that's fine. But when you think about smaller and mid-sized companies, they have broader audiences, and for them, it may, or not broader audiences, but they have different market segments, and it may be interesting to actually be speaking to people in various different ways to address them. So the personalization often comes later. Often we have the first adoption of the technology, and then we have almost in everything. When you think about shoes, when you think about cars, when you think about other technologies, we have the core technology first, and then we have personalization. And that's where I feel like our field is going to go. Okay, so the next slide, I'm going to show really what is happening because of the massive tech players, as well as a whole industry of new startups in this area. So prior to 2007, you have Sarah Proc, you've got Reed Speaker, you've got Nuance, you've got a number of other companies. I'm forgetting, or I can't put every different logo on here, but we had an industry of text-to-speech, right? And then in 2007, Apple comes out with the iPhone, right? When we get Siri. And then in 2014, we've got these personalized voices for a very niche market for people with speech disabilities. And when I would say you'd want personalized voices for all sorts of things, people would look at me as if I had 10 heads and say, why? Do I need my GPS to speak like my wife or this or that? The lack of imagination of why you'd want customized voices, because at that time, not that many things talked as much, but that rapidly changed because there were more and more devices. Lyrebird was another company that came out around that time. Then, of course, you've got Amazon and Google in 2017, 2018, really making a mark in this area, creating a lot more of the underbase of the technologies that you hear with Google with their duplex demos, really changing our perspective and what we can think about where voice can go. And what Google did very interestingly with the duplex demo that they had was, talking about the fact that disfluencies and the fact that you are not going to always want polished audio for some of these applications. You also start seeing some mergers. Lyrebird merging with Descript, which is a bigger platform, Well Said, Resemble, a bunch of other companies coming into place. 2019, more, we received Lovo here, Murph, Sonantic, 2020, then Microsoft in 2019 and Facebook in 2020 are entering the market, Veritone as well. So you're starting to see more of these. On the bottom line here, I put the FANGs, right? The Apples, the Amazons, and so on and so forth. NVIDIA comes in then in 2021. And I think with the newest purchase of Sonantic for Spotify, you're now also seeing these media platforms come in. So what I want to illustrate here is just how much both these big tech giants as well as startups play in this role, and all of the research community that is all of us that are contributing to that. So mass change here, and this is going to continue to proliferate, and you're also going to see more and more of, I think, these amalgamations or getting together with the smaller teams, with the bigger companies as well for differentiation purposes as well. Okay. So there's two main things. I want to go into use cases now. So when I talk about neural speech synthesis, there are sort of two main processes. And I'm just simplifying this as learning and inference. So in learning, we have these audio transcripts that then, audio and transcripts that are fed to a system that will go through and align the audio and the text and do all the QA and the prep and get it ready for the actual training. Initially, it's the training of the acoustic model and then the training of the vocoder model. And then we've got this voice engine. Now you can take that voice engine, which is essentially that acoustic model and that vocoder model, and then feed new novel text into it in inference, do this linguistic analysis, and then feed it to the acoustic model and the vocoder model to get the waveform. Okay, so most of the work that up until now has been in terms of the research community and also I think in terms of the work that's been happening in industry has really focused on core tech, right? Getting that acoustic model and that vocoder model, what are the different vocoders, and we've got the Blizzard challenges, and we've got all these things to try to get that piece and make those changes. But what I want to illustrate in this talk is that there's all the other stuff. And there are multiple places in which we can have impact. And I think a community like this is so interdisciplinary. It's not just about that core technology. It's only as good as the data, right? And it's only as good as the linguistic forms you give it, and so on and so forth. So with a few use cases, I want to illustrate what opportunities as well as challenges exist in this area. Okay, so first, the use cases back from 2014 to 2018 really were niche more in assistive technology, telephony, and in limited domain content. As we've got WaveNet and Talkatron variants coming in the last few years, the use cases can be more generalized to games and e-learning and short-form content. And I think that now, with the more improved technologies as well as understanding of what kind of data is needed for these models to work efficiently, we also have entertainment as well as advertisement and larger and longer form content as well. So I'm going to go through some of these use cases. It's not an exhaustive use case, but I'm going to go through a few just to show some of the challenges. So one of the big, I think, secrets is that this initial part about what audio and how clean the transcripts need to be had, and that audio prep part, I feel like that's one of the biggest secrets in terms of where we can make the hugest impact. There is most of us are using the LJ set, right? And there's other data sets that are out there as well. But how do we make sure that for novel data sets, we have the most efficient method of collecting that data, we have good audio to text transcription that's not too costly, it doesn't require too much human labor involved, and so on and so forth. So there's a lot of innovation that can happen in this space. In terms of recording, we had created a very similar user interface for talent. So we've been working with hundreds of talent now to have them record their voice to make their own voice replica for use in advertising as well as e-learning and all sorts of use cases, and they get royalty shares with that. So it's no different than what we did with the Human Voice Bank initiative, but now it's content curated for these different use cases. And different kinds of content is given for different use cases as well, so we can actually tailor that. So not only do we have this recording interface, but then we also have this reviewing interface where you can go back and listen and annotate and so on. And all of this can be done remotely. I'm only showing you images from Vocal AD because that's what I have access to, but of course, most of these other platforms will have their own methodologies for this, so just letting you know that. So the first area that I want to talk about, or the first use case, is content creation. And I was having a hard time trying to figure out how to call it, because it's content creation in all sorts of forms, for in-store advertising, for IVR, for radio and streaming. Essentially, it's trying to create content, not on the fly, but static content that you can then manipulate and modify and so on and so forth. And the longer forms would be for e-learning and so on. So it's an audio content production. It's not real time, it's not in dialogues, it's not for conversational agents necessarily. And here, you have, I'm going to play you some samples now. So just some samples of a variety of different use cases, and these were all produced by Vocal ID.
Thank you for calling the Community Health Center. To learn about our memberships, press 1. To book a trainer, press 2. For a dial-by-name directory, press 3.
You get the idea. So in IVR, the difference though here is we're trying to make those voices more diverse sounding. So one of the other I think the things that's happened socially is that people are more interested in having, at least I would say, I think this trend is definitely in the US, I'm not sure if it's all over the world, but having more diverse sounding voices so that we're not just hearing a very small monolithic part of our society, we're hearing the diversity of the voices as like the voices that are in this room today and listening. And the next sample here is more for advertising.
Combining its fun and responsive city driving capabilities with hybrid power, the new Toyota Yaris Hybrid truly is full of positive energy. When you have the energy to keep going, why stop?
The next one here is more of a PSA, but oftentimes that PSA, a public service announcement, it's important which voice is used for that. You can't just use Siri for that, or you can't just use a generic voice for that. So here's this one.
They aren't just barrels. It isn't just highway work. It's a community investment. In a world that can be in such a rush, here's a place to keep it slow and steady. Every driver makes a difference, so stay alert. Eliminate distractions and mind your speed. Good choices behind the wheel keeps us all safe. This message sponsored by the Wisconsin Department of Transport.
You can imagine that same script played with different voices in different parts of the country, and so you have different adoption, and different voices will appeal to different people. Oops. I don't know why that's not playing.
Special advertised offers reflect specific vehicle stock numbers listed in the supporting information for each offer and are available for well-qualified consumers with approved credit. Special offers may require financing or leasing through a particular financial services vendor or for a limited time and subject to change without notice. All rebates and incentives are to be assigned to the dealer. Some special advertised offers are independent of each other and may not be combined with...
Okay, so even for disclaimers, again, people who speak fast, who do those disclaimers, it's not just speeding it up. So that was one of the things we noticed when we were doing the work with patients with disabilities, is often, their devices, you could do things like speed it up or increase the loudness, but when you do things like that without actually creating voices that are recorded in that kind of sense, you're really going to distort the speech signal. So a lot of times the reason why companies want to use synthetic voices to create this kind of content is because of operational efficiency. To create spots like that, like I showed you, it could take them weeks to do. You have to go back to the voice actor. What if that voice actor is no longer around? What if they can't do it? What if there's a competition, whatever it may be. There's a lot of operational efficiency in doing that. That also is scary for the voice talent. So here I have the positives or the opportunities here, and the challenges are with the exclamation mark. The voice talent are afraid of this because they're wondering what's going to happen to their jobs. And so we have to think about things like their rights as well as royalties that can be paid to them and so on. So I think as a community, we have to be thinking about those things, not just about the technology itself. You can also do personalized targeting and also combine AI and AI and human recordings to make this hybrid kind of content. And that you're seeing now in dynamic advertising. In dynamic advertising, the intro and the outro for some of these dynamic ads that play to you for when they're personalized ads, the intro and the outro might be recorded, but the middle parts that are changing, that are dynamic, that are about the geography or whatever, would actually be synthetically generated. Okay, so in this world, there's a lot of work that we can do in terms of curating better audio, the labeling the different styles so we can get different styles, and also making sure that the scripts that are given to the speech synthesizer are more about how people want to be, how people want to listen. We train speech synthesis with read speech, but then we expect speech synthesis to sound spoken. And that is one of the, I think, the rubs here, is that we actually need to make sure that the scripts themselves sound good so that they're more spoken. And then we want to be able to control the SSML, the markup language, and the lexicons as well. And then, of course, as you saw in most of those samples with the DSP changes, as well as adding music and so on, there's much more you can do with the final waveform. So here I'm just showing a couple of slides on some of the changes in this graphical user interface that we built around being able to show, to make changes in speed and pitch and tone and so on. And here, this is the Speech Science Geek coming out, where there's the actually being able to phonetically spell. And so yesterday we heard some work about phonetic spelling as well as graphic spelling, so you can kind of do the combination of the two together. As the speech is getting more and more sophisticated, we can add emotions. And here's a sample from Sonantic, another company, about creating humanized characters that can emote. So I'm going to play this sample.
I can still hear voices. Sometimes, if I'm lucky, I hear her. And it's like she's right here with us. Her warmth, her love. And it's her. I just don't understand. What did I do? Faith. There's something you need to know. Mom.
Sorry. You can really hear, I'm just going to go back one slide. Oh, I have to play that again and stop it. So what I wanted to illustrate here is that you can have some powerful storytelling with some of this for short form content, I think. But there is sometimes an uncanny valley that happens as well, and that's one of the things that I feel like that'll be our next challenge. So on the one end, we want voices to be so clear, but then we also are afraid of, well, what if it sounds a little creepy, right? And so that's the next challenge, I believe, too. So for expression, I feel like, again, curating the right content is so important, the right corpora, and then learning those articulatory styles in training, and of course, all the modulation as well. The next use case is for celebrities and influencers. And I think this is where it starts to get a little bit tricky and dicey, because, and you've seen this a lot in the media, right? With these various different movies that have been out there, there's been some great work done by companies like Respeecher, Sonantic, Resemble, in this area. But one of the things that is the challenge is the ethics and the estate rights and so on and so forth. And even, I think, at this phase, we don't know how to consume synthetic media in the same way as we know how to consume synthetic audio in the same way we know how to consume synthetic video. So with CGI, we wouldn't go, oh, I need to know whether that's CGI or not, right? We want it to be more and more hyper-realistic, but when that voice is hyper-realistic or we weren't told, I think we're at that beginning of that dawn where we're still a little concerned about that. So it's going to be important. And now you're also hearing in terms of not just famous people, but also recording family members and having those voices so that you have them for longevity as well. Okay, so here, when you're recording these influencers, you might not have enough data because they might not sit for your training data, and so you might actually have to augment. You might actually have to augment their data with pre-recorded samples, and those pre-recorded samples then will provide another challenge in terms of how to make sure that that data is the same as from various different groups of data, so that we don't have room acoustics and all the source filter, the source separation that's going to be necessary to make that voice sound good and clear, so it doesn't sound like it's in two different environments when it's speaking. Okay, and also in terms of influence and celebrities, I think the protection of the voices becomes a real issue. And I think it's not just for celebrities and influencers. I think it's going to be, if you and I had a voice built, we won't want to have that voice being used by someone who hacks our system and then, our model, and then uses it to get into our bank, for example. This was work that we found ourselves in back in 2018, where banks were very scared about the fact that we were making customized voices or personalized voices for people with speech disabilities that were really cheap and easily accessible. They thought, well, what happens if there can, now that we're using voice biometrics in banking, what happens if that model is stolen, right? And they were worried about, of course, for their high net worth individuals. So we did some work with them. And we thought, this is 2018, so it was like the DNN voice. We thought, there's no way that the DNN voice is going to break through the voice biometric system. Unfortunately, there is, and there was at the time. And we found that there was, it's not because humans couldn't detect the difference. It's because there were machine layers that could not detect the difference between those DNN voices and the voice biometric systems. Of course, there's been changes now to think about, I feel like counter measures in terms of biometrics is always one step behind. It's like a game of whack-a-mole. You create a new method, and then you have to figure out a classifier to make sure that voice doesn't get misused or abused. There's also a number of industry partners now trying to create these proactive measures as well as regulatory best practices, including the Open Voice Network. There's also SAG-AFTRA, which is the union for voice actors, as well as an organization called Athos, which is a number of us synthetic media companies, the smaller companies that came together to make sure that the technologies that we create do not unintentionally and inadvertently create misuse. The last use case I want to talk about is real-time conversational speech. And here, I'm actually not going to play the audio because I was worried about the acoustics in here. But here is an opportunity, I think, to take real-time feeds of scores and games, feeds of the weather, the stocks, whatever you want. Now we have synthesis with latencies that are capable of being much more conversational. And we started seeing this in the bigger companies, but I think it's for the smaller startups where how do you make a voice for a few $1,000s that can actually still be running in real time like this. And so here you can increase, audience share, speed up to market, the speed to market as well. But some of the issues and the cautionary tales here are around the complexity of those use cases and maintaining engagement. So if you have scripts of how you're going to say the score and there's 1,000 different plays in a particular game, how do you make sure that the audience is in fact engaged? So that's where the linguistics is really going to come in, so that we can make sure that when you're watching this kind of, or listening to this kind of commentary with synthetic voice generating that commentary, that it's engaging. That's hard, I think, in real time, for real-time audio, and it's also hard for continuous synthetic speech. So there, again, I think the biggest challenges are going to be in the audio curation as well as natural language generation. How do you make sure that the templates that are used, or if you're learning those methodologies, you have good enough data to train them? What I'm noticing here at this conference is all the data companies that are here. And that's because the need for data with these new models that we're creating is just exponentially growing. Okay, I just want to wrap up now with just the summary of the open questions. So one set of open questions is, of course, having better quality audio. We'll always be pushing for that better quality audio, the better models, and so on and so forth. But also the adjustments of the lexicon and learning those lexicon adjustments over time, things like the SSML and the tone changes. So prosody is a big one. I feel like there will be much to do there now that intelligibility is high. Now working on naturalness and working on the control, the fine level control of prosody is a big one. And also I think one of the things that it's often been sort of an either or question, very black and white, you know, can we have synthetic voice or human voice? Well, why does it have to be black and white? Why can't it be a combination of synthetic voice and human voice? Why can't we combine those together? I think we can, and I think that's where new media has massive opportunities. The next sort of group of open directions is reduced training data. There'll always be a need for that for the smaller companies. Not the bigger companies because they've got unlimited budget and unlimited whatever else, but it's the smaller companies that are going to be really focusing on the branded voices or the voices for individuals because that's not the business of the big companies. That's not really what they're situated for, right? They're going to be pushing the envelope for the core tech, but not the customization piece, at least in my mind. Model compression. So many of these models are great on the cloud, but they can't be used on a mobile phone. And many of us want the synthesis to be, if it's a custom voice or it's a unique voice, to be on the phone or on device or in a car or whatever else. And so working on that, I think there's going to be a lot of opportunity there. Probably ICASP is sort of another audience that could contribute there. Accelerating the build time or the learning time, and also reducing the conversational latency, or reducing the latency between creating the text going in and the audio coming out. And without that, you know, you can't actually have a conversational system. In terms of modulation of context, so most of speech synthesis today, we're talking about some text going in and the audio coming out. But how does that text change, or how should the modulation, how should the articulation of that text change depending on the spoken context, the dialogue context? There's a lot there to be done, as well on the natural language generation, as I said, if you're going from metadata to speech. Cross-language adaptation, we've seen a few talks at this conference, and there's more of this. How do you make a speaker who doesn't speak all these multiple languages? Like this week, I wish I had Korean voice synthesis for my voice, and that I could have spoken and interacted more with people in the native language, even though I don't speak that language, trained for me personally, right? And there's, I think, an unbelievable amount of application in health and education for personalization. These are two industries that typically lag in terms of adopting new technologies, but in terms of what can you do with a personalized voice for someone with dementia? What could you do in terms of a voice that's more regionalized and you know, to a particular group of children so that they want to learn this content? It isn't a generic voice that they're listening to, that they're engaged more. There is so much opportunity for speech synthesis and voice conversion in areas outside of entertainment, like the use cases I talked about today, in education and in healthcare. And I hope that we're going to see much more of that in the coming years. And the last sort of big section is on the improved data insights. So, you know, oftentimes with the neural models, we don't know what the interconnections are, and we need to unpack that a bit more to better understand what the models are doing, what kind of data impacts this model, and we need to get beyond word error rate and the mean opinion score. So what are other kinds of ways in which we can evaluate these systems? And I've heard a few talks this week, which I think are really exciting. And the last is, what use case for what voice? And I think this is a big question. I don't have as much time today to talk about it, but voice is personal. Voice is really about your identity, and what appeals to me in a given context for a given use case today may be different than what appeals to me for a different context tomorrow. And so it's really important to think about how we're thinking about voice. It's not just that, oh, because my last name is Patel, I'm going to want to have a certain accented voice telling me about something in, customer service, right? So it's really important for us not to take the biases of what we know about voice and inject them into the way that we're using voice in all sorts of different applications today. So I think that there's a huge opportunity here for scientists from all of our disciplines, whether it's linguistics or speech acoustics or speech pathology, machine learning, all of these different areas to come together and make these new advances. So with that, I want to end with what I call the AI moonshot, which is, and I'm going interchangeably between speech synthesis and AI, because I guess these days that's what we're calling it. I think the moonshot here is, with all those challenges I showed you, as well as some of those opportunities, is for AI voices that are convincing without being deceptive, that connect us rather than divide us, which is a big, important part, that benefits us all, not just some of us. So that means people with disabilities as well, that celebrates our diversity and makes us a little more human rather than making us less human by having these artificial voices. So thank you for your time. And I think I have 4 minutes for questions if anyone has any. Thank you.
Thank you, Rupal, for such an interesting talk. I really enjoyed that. Are there any questions anywhere? Anybody?
A couple of.
Got to be some people. Oh, yeah, right there. Antoine.
So thank you for this very inspiring talk. Of course, what you talk raises the question of the identity. So what is identity when we speak? What is our identity? So you had a strong focus on identity is in the source as opposition to the filter. I also come from the world of the filter.
Yes.
And I think a lot of identity lies also in the filter, but it's a bit more subtle maybe than in the voice.
Yeah.
So what is your view on that, and what do you think are the challenges to cope with this big question of identity in general?
Yes, thank you for that question. I don't think identity is just in source. For those individuals who had such severe speech disorders, getting identity from their filter wasn't useful, because for them, their articulators don't move well enough. And so we don't want that identity aspects, because that would be distorting the speech signal. So it's only for that use case that we're saying that it's just the source identity that we want. For most cases, we want the source and the filter identity, because identity is in both of those characteristics. And it's also, in many ways, in the projection of that voice as well. And so, yeah, I absolutely agree that identity does not just live in source. But for those individuals, we had to separate it. Otherwise, we'd get distortion.
Okay, thank you. I see a hand over there. Oh, there's someone else too. Sorry. Okay, John.
Well, you had two people in the back that should have gotten it first, but
That's okay.
I'll just say that personally, I would have liked to have seen the TI Speak and Spell partly because we didn't raise a generation of children that sounded so mechanical like that. Let me ask one question. If you look at all commercial high-end color photocopiers today,
Yep.
every one of them puts a digital mark on every copy they put out. And so when you look at the forensic analysis of people trying to produce money, I guess, they can identify where it came from. Could you comment, are there any standards committees or groups that are looking at trying to put in a digital watermark into the synthetic voices
Yes.
to preserve both ownership and also to track those voices, so this way we have some way of tracking who originally created them and who owns them? I think that's something that would help a lot on the forensic side.
Absolutely. Thank you for bringing that up, John, because I had it on my slide and I think I raced through it. Almost all of the companies are now putting watermarks in the voices, which is actually called audio steganography in audio, right? The only issue is that having the watermark is important, and making sure that it doesn't distort the signal, right? But what's really, I think, important is for us to create a standard around how those watermarks are then used. Because just because you have the watermark is just like one piece of it, right? The next piece of it is to make sure that those watermarks are, pardon the term really here because I'm going to use the word blockchain. There's got to be some kind of group of people or industry that's monitoring that and making sure that those voices are not being abused, right? So in terms of audio production, there has been always there's a whole industry of making sure that if you recorded a sample, that sample is not being used on TV or some other place and without the rights, past the rights, you know? But I think in synthetic audio, it's hard to have that. We don't have that as an industry yet. But that's part of what the Open Voice Network and for other organizations now are trying to see if we can do that. But I think for regulation, that is going to come down the pike for sure. It's going to be very important. So thank you for bringing that up.
Okay. There was a question back there. Coming. Over there.
Hi. You raised this point about that we tend to train on read, directed speech, a voice actor reading a script, and then expect the output to be conversational somehow. I wonder if you have any ideas or suggestions to how to address that discrepancy or collect more conversational data.
I think we're starting to see, I mean, Esther, I think you're an expert here in terms of some of the dialogue aspects of it. We are seeing people, groups trying to create more conversational dialogue in the actual collection of the data. How do we, in terms of other ways to collect that data more efficiently?
Yeah, I had a survey talk on Monday about that exact problem. So what we are doing is trying to figure out if we can have a more interactive dialogue between voice talents and also make sure that the material that's being recorded is more suitable to the conversational domain. So yeah. It's happening. We're working on it.
And the other thing that we're also doing is there's a number of people that are taking pre-existing data of conversations and using that data then to train a voice. The problem there is just the time to clean out the two speakers talking over top of each other, and it's the cost of building out that voice when you have a pre-recorded data. But I think that's where, if we want it to sound like it's more conversational, we actually have to collect conversational data as well.
Thank you.
Shri? There's a couple on this side.
Shri, do we have time for another question? You got it.
Thank you. Thank you, Rupal. Wonderful talk.
Thank you.
Super enjoyed it. So I had more of a sort of question, philosophical thing that I wanted to get your comments on about the whole construct of identity. It's a very social and personal construct, and voice provides one means for expressing it. At the same time, right, it's a very dynamic thing. Both what one is given it changes. For example, aging, effective aging, and other things. It keeps changing over lifespan. But also how people choose to use it for expressing themselves as an identity. Since you use the term identity, love to hear your thoughts on what opportunities and challenges exist as we move forward, where technology can play a role in supporting this, where it needs to be, or not enter that.
Yeah, I mean, I think that I feel like there are many applications. I mean, some of the work that you're doing with kids with autism, right? How do they hear their voice? I think a lot of times it's both the listeners, how it reflects on the listener, but also how it reflects on the speaker. So I think in terms of identity, that identity doesn't just live in the speaker, but it also lives in the people who listen to them, right? And so I think that you talk about things like, how does your voice change over time? All of our voices are changing over time, and so our identity is fluid. It's moving, and it's changing as our bodies change, as we grow, for example, right? The voice of our children is no longer the voice as they get older. So I feel like that's one of the things where it's so personal and yet so much, I don't know how to explain it really. It's a continuum, really, if you think about it. And I think that's the part where if we can continue to evolve it. So for many of the people that we were building voices for, we were also going to be aging their voices over time because their voice won't stay the same. And the voice donors often may be someone new when they become a teenager because they might want actually a different voice. They might want to try on something a little bit different. So identity is not, one thing we learned, I think maybe this is a better answer to your question, is when we were initially building voices for people who couldn't speak, we thought the important thing is that the voice represents them more realistically. So it should sound like a person is really small. It should sound like a smaller person producing that voice. It should be actually accurate. Accurate production is what we were really going for, right? Or an accurate sounding of voice that should resemble them. And what we learned, the biggest lesson we learned, is that accuracy wasn't what they wanted. They wanted what they preferred. And so it goes back to Kodak and Polaroid, right? The war between Kodak and Polaroid in the visual world, right? There was a war between accuracy and preference. So do you want to look green in pictures, or do you want to look more pleasant looking in pictures, right? Guess what won? Not accuracy, preference. And so that is one of the things that we learned is that, again, who the voice is for, it has to be, they have to like it and prefer it. And it's the people around them that also get to make that decision. That's a little bit challenging when you start thinking about people with different disabilities, because who's the user and who's the buyer and all those kinds of things. But I think that's one big lesson. I think as scientists, we are so focused on accuracy, and we forget that humans really, it's not just about accuracy, it's also about preference.
Do we have time for one more question?
There's one way over there, and there's one over here. There's one over here. This guy here had his hand up for a bit.
I'm sorry.
Hi.
Hello.
Just to be a bit provocative, there are several speech scientists in the room. You have only one slide about using speech synthesis to better understand human speech. For me, I see speech synthesis as a way, in fact, to compress massive data into a comprehensive model, to use this as a general statistical tool, to perhaps to probe, in fact, the degrees of freedom of human communication. So could you comment on this? So
actually, at the
what
beginning,
is the impact on speech science?
Yeah, well, at the beginning of my presentation, I played, I don't know if you heard it, but I played a bunch of samples of early models of speech synthesis, which were all about actually scientifically understanding the human speech production and what what the quest is of humankind in terms of understanding speech, from mechanical models to acoustic models to model-based synthesis and so on and so forth. So I don't know if you were here for that or not, but definitely believe that speech synthesis is all about, there's a lot in speech synthesis that's about understanding human speech production, not just as adults, but as children, and the developmental course of human speech production. So absolutely.
All right, thank you. I think we're going to end it here. And anybody who has questions for Rupal, you can find her roaming around. So thank you, everybody.
Thank you.
Thank you, Rupal.